Good afternoon, everyone. This is Chris Jorgensen, Director of Marketing at Unleashed Technologies. We're going to be waiting about one more minute here just to let a few of our late joining attendees trickle in here. All right, good afternoon, everyone, and thank you for joining us for today's webinar, Demystifying Blockchain Technology. My name is Chris Jorgensen, and I'm the Director of Marketing here at Unleashed Technologies. Our team has seen an explosion of interest in this topic over the last 3 months, and we're confident that you'll find the content presented today provides a strong foundation on the subject. As we get started, we ask that you take a few moments to complete a survey, and you'll see the link on your screen now in the lower left-hand corner. Now, for those of you who don't know us already, Unleashed Technologies has been dedicated to creating award-winning websites and digital experiences for our clients since 2007. We have a particular focus on open source web technologies, with our primary platforms being Drupal and WordPress. Our team is always watching for emerging technologies, and a few of these technologies that we're tracking right now include virtual reality, progressive web applications and personalization, voice assistant technology like Alexa and Google, and of course, blockchain technology, which we're going to talk about today. One quick note is we'll be saving our question and answer section for the end of the presentation, but please do provide your questions as we go. At this time, I'll be turning things over to Scott Greenwell, our Chief Operating Officer, who will be leading today's webinar. Scott?
Thank you so much, Chris. A little bit about me. My name is Scott Greenwell. As Chris said, I'm the Chief Operations Officer here at Unleashed Technology, and I'm also one of the co-founders and original operators here at the company as well. I know that we had a brief moment to do the survey, so hopefully a few people have taken that. I'm going to go ahead and move into our presentation and start talking through our slides. One of the big reasons I asked for everybody to take this survey real quick was to get a general consensus of sort of how people feel what blockchain is being used for today. It's kind of a cheat question because everything on this list is currently being used as a blockchain application or is in process of being developed as a blockchain application. And yes, including breeding digital cats. So what are we going to actually be covering today? Today we're going to cover an overview of blockchain technology, why would you use blockchain and how it can be applied to associations, and then a few comments on looking to the future and places to go next if you want to continue learning more about blockchain. So that said, let's talk a little bit about what we won't be covering today. We will not be talking about blockchain and cryptocurrency investment strategies. We are by no means financial analysts, and that sort of research you would have to do on your own. We are not going to be covering which blockchain or cryptocurrency is the best. They all have different uses, and so there really is no best or better blockchain application. We will not be covering how to build blockchain applications. This is very much an overview introductory course. So it's going to be covering the uses of it, how it functions, and why we would continue using this. And then lastly, if you are interested in how to mine cryptocurrency, again, we will not be covering that in today's, but the links that are provided at the end of the presentation, if this is something that is interesting to you, would be available through those links and application links. So what exactly is blockchain? Blockchain is a shared distributed ledger that facilitates the process of recording transactions and tracking assets in a business network. It's comprised of unchangeable, digitally recorded data in packages called blocks. Each block is then chained to the next block using a cryptographic signature. This allows the blockchains to be used like a ledger, which can be shared and accessed by anyone with the appropriate permissions. This function of chaining these blocks together is where blockchain derives its name. In its simplest form, it really is just a new way of storing and sharing information. The two most important points in this definition are the distributed ledger and the block's cryptographic signature. It is in these two details that really define the power and adaptability of the blockchain. So let's explore these two concepts a bit further, starting with the distributed ledger. One of the best examples I've seen in explaining this concept was a history lesson that was put on by the West Pat Group. Now, their story begins back in 500 AD with the Appeased tribe on the island of Yap. This island is located in what is known today as Micronesia. The Appeased had a currency made of stone quartz called a rye stone. This is a rye stone. Rye stones were generally large circular discs with a hole in the middle. The stones varied widely in size. Some were larger than 3 meters in diameter, half a meter thick, and they could weigh almost as much as 4 metric tons. So spending these like traditional coins was a bit difficult because of their size and their weight, but the Appeased really solved this by never actually moving the coins. Instead, the coins were placed in prominent locations around the island, and every adult Appeased knew who the owner of a coin was by memory. If two people wanted to transact, they would announce it to everybody on the island, and from there, looks like it locked up, sorry. They would announce it to everybody on the island, and who would then, everybody on the island would update their knowledge of who owned which stones. With this announcement, that coin was exchanged. The Appeased were using what we would call today as a distributed ledger. It was a ledger as each Appeased had a recollection of who owned what coin, and it was distributed because it wasn't just known by one person, but by all. Now, the Appeased could have asked one person to keep track of the mental ledger, and that person would have needed to be very trustworthy, both in terms of honesty and in administrative skill. The monopoly that that person had could have led them to charge a fee or impose transaction limits, or when times they could actually make transactions. Problems could also arise if that person left, fell ill, or if their integrity was compromised in some way, making the system vulnerable. In today's standards, that central person would be a bank. Distributed ledgers provide many bank-like functions without requiring the trust in a central authority. So in the Appeased example, a member of the tribe couldn't just arbitrarily take ownership of a stone, because if there was a dispute, the tribe would be able to state the correct owner by validating it with other members of the tribe based off their own knowledge of the ledger. So fraudulent transactions weren't likely. Also, if one particular person of the tribe was not available or moves away, thereby losing a copy of the ledger, transactions can still be validated by other members of the tribe, making the system fault resistant. The most interesting part is what happens if a coin gets destroyed or lost. In one example, a large storm came and a rye stone fell overboard during a voyage to the island from where it was being quarried. To the other Appeased tribesmen, this really wasn't an issue, as they could imagine the coin sitting at the bottom of the ocean. So the tribe then mentally added this to their ledger and continued to use it for transactions like they did with all the others. So even if in all intents and purposes the coin didn't exist, it could still be used to transact. Now, as I mentioned before, distributed ledgers are only one of two key concepts for blockchain. The second is the use of cryptography, or more specifically, cryptographic hash functions. To explain this concept, let me tell you how we can distill the entire Lord of the Rings trilogy into just 20 characters. It turns out that every book has a unique, untraceable fingerprint. There are certain functions, by which I just mean mathematical equations that computers use, where if you put in a book or a string of characters, you get out the other end a unique 20 to 30 digit code. This code is unique to any given input, So when you put the Lord of the Rings into this function, you would get a 20-digit code like we see here. If you put in an exact copy of the Lord of the Rings with one additional comma change, you would get an entirely different 20-digit code. These codes would be so different that you would be unable to connect either code to one another or the original version of the Lord of the Rings. Now, functions that do this have some pretty amazing uses. You can use them to validate information. Let's say you were about to sign a lease, and you wanted to make sure that you're signing the same copy as your landlord. You could drop your version and the other version of this lease into the function, and if there was even a comma difference, they would produce different 20-digit codes. If they both produced the same code, you could be confident that you're signing the exact same copy of the lease that your landlord is signing. Now, you can also use functions like this to obscure your identity. You could combine your personal information, your name, date of birth, hair color, into a string of text, and you can put that text into a function to generate a unique 20-digit code for your identity. You can then use this as your internet identity to conduct business online, confident that no one can connect it back to you directly. But later, if someone wanted to verify that it was you who owned the code, you could show that you're the only person that knows the combination of inputs that can regenerate that code. Now, we've covered both the cryptographic hash function and the distributed ledger. So let's try and start putting these two building blocks together. So going back to our Appeased example, we learned that distributed ledgers allow for transactions to occur even when a coin doesn't exist, just like in the coin at the bottom of the ocean. We also saw that it's nearly impossible to steal coins. This is because each Appeased who owns a given coin and knows everybody else that owns that given coin and whether any transactions have changed that ownership. Now, let's imagine that these ledgers, instead of being stored in people's heads, are now stored in computers online around the world, managed by incentivized volunteers. It would still work just like the island. Each computer would have a copy of the ledger showing coin ownership that's visible and known to everyone. And every time a person wanted to make a transaction, they would just announce it to the computer network that they wanted to send coins to someone else. All other computers, upon hearing that announcement, would update their internal ledger by deducting a coin from them and adding it to the recipient. We would only be missing two things to make this workable in the real world. The first thing we're missing is a way of disguising the identities of the people on the public ledger, as I'm sure most of us would not want to put our names and transaction history in public view. We can solve this with our hash function. Each person's identity details can be reduced to an encrypted 20-digit code where only the owner knows the input to generate that code, thus anonymizing those participants. The second thing we need to make this workable in a way is a way to quickly compare these ledgers between computers to make sure that they're starting from the same version of the transaction history. This can also be solved with that same hash function. Each computer can turn its copy of the ledger into a 20-digit code and compare it to the codes produced by other computers. If the codes are the same, then it's likely that they represent an accurate view of coin ownership. Implicitly, this makes it almost impossible to tamper with the ledger, because to do so, a person would have to tamper with thousands of different copies of the ledger stored independently on computers around the world, all at the same time. In this example, we've just created Bitcoin. Bitcoin is a distributed ledger secured through cryptographic hash functions to transact invisible coins, and anyone can join this network, creating a 20-digit digital identity. So why would I use a blockchain over a regular database system? If you're looking to share information and data entry across organizations or across a large group of people, the information needs to be publicly auditable. It also needs to decentralize control of the protocol. So I don't want any one person to be able to change or modify the ledger unless they have the given access. And I'm also looking for a way of creating immutable assets with a trustless authority. So the entire public then becomes the trusted authority. So before we get into some examples, I wanted to cover a little bit about the differences in blockchains. There are really three different variants of a blockchain. You can have a public blockchain, like our Bitcoins and Ethereums, or you can have a private blockchain, similar to our Ripples and privately owned blockchain applications. Private is where most of our businesses and our associations will be using or leveraging this technology, and they'll be building off of a public blockchain. Now, the difference between these is that a public blockchain, any person has open access to read and write to the database, and anybody can access this information by creating that 20-digit code. They're generally going to be a little bit slower because they're using a larger community of computers to process that information. And they're generally going to be secured through something called proof of work or proof of stake. Now, these are two different models that if you go into some of our continued reading afterwards, you can get how the differences between proof of work and proof of stake works. But in the grand scheme of it, they're all using the large open network of computers to process that information. Identities on a public network are generally anonymous or use some sort of pseudonym. And assets within those blockchains are native to the public blockchain that was created. The other downside to a public blockchain is that it's expensive because we have power costs associated with the millions of computers that are trying to process this information, much like we've heard in stories about Bitcoin and Ethereum and the amount of power consumption that those require. Now, on the other side of the coin, we have private blockchains. And private blockchains are created by a company, organization, or group of people, and their permission to read, write, access to the database is only given to authorized participants. So by only having those authorized participants, these private blockchains are much faster. We have less computers processing this information, and the security is generally done by pre-approved participants. So in the case of Ripple, which we'll cover here in a little bit, it is a private blockchain that only allows banks to join and become one of the miners or one of the data processors of this blockchain. Some of the advantages of this is that every person that joins that network is then a known identity because they've been given permission. The assets that a private blockchain can store can be anything. It can be whatever the creator of the blockchain deems as a storable asset, in this case, data. Data can be anything from a financial value to documents to website information like usernames, logins, and passwords. Now, this all boils down to a much cheaper cost to run that private network as well. The last component is that when you set up a blockchain, you can actually do a split between these. So our mining participants on Ripple, as an example, are our banks and our other institutions that are processing the information. But they have a public component where I, as an individual user, can create an account and be able to transact in Ripple. So theirs is actually a shared between a public and private blockchain. So before we jump into, again, some of the examples of what this is being used for currently, let's take a look at how large blockchain is in the global economy. A study posted on howmuch.net in June of 2017 compared the value of all cryptocurrencies in the world to the amount of money available globally. To put it into perspective, the entire economy of the world is valued at just over $83.6 trillion. All of the world's physical money, aka money that can be used as a medium of exchange, dollars, euros, online credit, things of that nature, is valued at about 31 trillion of those dollars. All of crypto in June of last year was valued at just over $100 billion, just slightly ahead of Bill Gates' personal fortune. The largest cryptocurrency at the time, Bitcoin, made up 41 billion of that 100 billion market share value, but it's far from the only one. There are currently thousands of blockchains, and the number has only continued to grow as more companies adopt the technology and find uses for blockchain. In fact, since June of last year, we're currently 550% more valuable than it was 5 or 8 months ago. We're currently at $550.2 billion as a crypto asset. Now, let's take a look at some of the uses of blockchain and understand how we're starting to build this value and what the community is using to achieve a decentralized ledger. So currently, associations and other companies are already using blockchain technology for payment and money transfers, smart contracts, governance, digital identity, supply chain communications, document storage and proof of provenance, gift cards and loyalty programs, and other networking and Internet of Things applications. I'm going to dive into a few of these examples just to showcase some of the versatility of this technology. The first thing I want to jump to is what most people put in our survey is payment and money transfers. This is where everybody goes to initially when they think of blockchain or cryptocurrency. The goal of these particular blockchains is to remove the middleman by allowing a direct peer-to-peer transfer of value. It lowers transaction fees because I don't have a bank or some sort of central authority processing these transactions. And all transactions are then managed on the same ledger, thereby giving us access and view into where money is going and who holds it. This removes the ability to double spend money, which is also a current problem in our financial industry. And it acts as a trustless entity without actually providing trust in one particular party. Because these are not government-issued currencies, you're able to do international transactions very easily without going through, in some cases, 3 to 9 different parties to send money, in our cases, from the US out to an international location. Bitcoin, Ripple, and Dash are blockchains that are specifically meant to solve payment and money transfer problems. Now, another really exciting example of blockchain is something called smart contracts. Smart contracts are computer code or a digital contract, and it's essentially a self-executing agreement that converts transaction deals into computer code. The data is then stored inside of the blockchain and run by an international network of computers every time a new block is added to that chain. These contracts can be set up to either execute once when the parameters are met, much like if I were to bet you that tomorrow's weather is going to be sunny, or they can be processed every single time a block is added, like in the case of Arcade City here on the bottom right. That smart contract is actually aimed at replacing the entire company of Uber as a digital contract, thereby removing the middleman of Uber and allowing each Uber driver, or in this case, Arcade City driver, to run their own ecosystem and their own sub-business without any need of somebody processing and funneling money to them, utilizing more cost and more bandwidth. Other good examples of smart contracts are CryptoKitties. This is the breeding of digital cats that I had mentioned earlier. So CryptoKitties is actually a game application in which I can purchase using Ethereum. I can purchase an initial cat, and then I can breed my cat and then sell those to other people to then breed more cats. It's a very interesting use of blockchain while still processing financial transactions and using a smart contract to determine what type of cat I'm going to get out of this breeding. Other good examples of smart contracts are Golem and Storage. Golem is a smart contract aimed at decentralizing computer processing, paying you for a share of your processing power, and allows large organizations to process massive amounts of data shared across these millions of computers. Storage is similar, but instead of looking at computer processing, they're trying to sell your unused hard drive space using the blockchain and smart contract technology. Smart contracts, again, are programmable, self-executing agreements. They can act as escrow. So when I create a smart contract, I can preload it with an amount, as in the case of my bet example earlier. If me and another person wanted to bet that I think it's going to be sunny tomorrow and they think it'll rain, we can both preload our $20 or 20 Ethereum into that contract. And as soon as all of the parameters are met, tomorrow at noon, if it's raining or if it's sunny, it will then pay the person that won that bet. And nobody has to be that trusted third party to hold that money in escrow. Now, another example of blockchain in today's uses is governance, especially when we think of associations which are managing hundreds of different companies. You can programmatically create a democratic structure and allow the blockchain to act as that voting, either by giving some participants access to the voting rights based off of their share, or other predetermined virtues, such as maybe they're the chairman and they have an override value. These are all things that can be programmed into the initial contracts once they've been created. This allows us to be auditable, because at any given time, any of the participants can look at the blockchain and see if voting has happened and if it has followed those rules. It can reduce fraud because we have a computer monitoring the rules, and it's a very yes or no. There's no middle ground in a computer program. And we can create digital corporate structures out of thin air without the need of having somebody sitting there monitoring that corporate structure's activities. Democracy, Earth, AST, and IBM are all trying to solve this problem in particular. Democracy Earth is extremely interesting in the fact that they are trying to create an open, public, democratic body that encompasses the entire world to vote on prominent issues such as global warming or trash and waste disposal. Now, another really good example is the use of digital identities. So this isn't nearly as much of a problem here in the United States, as we have a very built-out company and infrastructure set here. But if we think of places like Africa, where I'm in the middle of the jungle and my closest bank is more than 100 miles away, how do I issue an identity or track birth certificates in these very small communities that don't have access to the infrastructure we do here in the US? BitHub Africa is trying to solve this by giving those remote users a digital wallet, or in this case, an issued ID by the government or by an association that stores information such as their transaction histories, their banking histories, birth certificate information, and in even some cases, passports and residency. This makes it accessible, devoid of wherever they are. As long as they have a phone, they're able to then access these infrastructures that we take for granted every day. And because it's on an open, decentralized blockchain, it prevents against identity theft, because the only people that then have access to create or access that wallet are the people that know the information that they put through that cryptographic hash function, as we described earlier. Showcard and Bloom are trying to create digital ID cards that we can then use as a global set for website application logins, access to banking and other routed information, and even trying to provide zero identity proofs. So when I try to apply for a credit or a loan, instead of providing all of this information to prove that I am who I am, I can show them one of these IDs, and that is proof enough that I am who I say I am. Now, another really cool example of digital identity and passing that through was actually the World Food, the World Food I forget what the P stands for, and I am so sorry at this point. But essentially, this is meant to try and provide food to people that are in need, like Haiti, or even when Aleppo happened and people were being attacked by Russian and other areas. They were actually able to send funds via Ethereum to these people behind enemy lines without ever meeting a single person. So those refugees that were fleeing Aleppo were then able to use that wallet that was created and funds that were given to buy food, shelter, and other necessary medical supplies once they reached the borders of their country. Now, I'm sure that in this sort of description, supply chain communications is another way that we can leverage blockchain and tracking technology. With supply chain communications, we can improve visibility of product from start to finish, such as the case of the International Pole and Line Foundation. Their goal, very similarly to the Soil Association's goal, is to track food from the time it's in a fishery or from the farm all the way until it hits the end customer. Now, every time a fish is born and sent out from the fishery, it is then tracked as a single coin or a single unit in the blockchain. And every time it hits a new person, I'm able to track it every single step of the way. Now, this may seem very novel, but let's think about this in the term of bad products. So we have tuna from a fishery that's working through and eventually gets canned at a factory and then is sold to shopping markets and then to an end user. Well, what happens if we have to do a recall on this tuna because one of our factory processing units was poisoned or malfunctioning in some way? Instead of just saying every single can that went through the manufacturing plant is bad from this date to this date, incurring a lot of loss, we can say and know exactly which cans were processed through this machine, and I can be very granular on the fact of which cans are being recalled and which ones are not. Now, this allows us to put timestamps on all of those transactions. We're able to trace paths both forwards and backwards from a particular point in the example of a machine breaking down at the factory or the cannery. It's two-party verified every time I move it from one location to another. So it's leaving the factory and going to the grocery store, as an example. Both of those parties are a part of that transaction. And it reduces costs for defects and any sort of recalls, as we examined earlier. Now, in a trucking or a transportation mentality, BETA, the Blockchain and Trucking Alliance, is trying to do something very similar for shipments and packaging. So right now, if I send a package from California to Maryland, it's going to hit 5 to 10 different people's hands, from airplanes to trucks to personal deliveries and the starting warehouse and the end location. At each one of these points, I would then be able to transfer a singular package from one user to the next, just by scanning the edge of the tag, much like we see with FedEx. Now, why wouldn't we just use FedEx's API or put our trust into one company? The reasoning is that if we were able to successfully implement, or if BETA is able to successfully implement this, we may see that UPS, FedEx, and international carriers are all on the same ledger. So instead of tracking my Amazon package from California or internationally, maybe it's coming from China, I have to go to my Chinese transaction log to see where it's at. And once it hits the end of that, I then move into UPS or FedEx's API. Instead, I can just go to one location and see it in the entirety of its transportation history. Now, one of my last examples in this set is document management and proof of provenance. So trying to understand document revisioning, who owns what document, what version am I on, is this public or privately accessible? We can do all of this, again, in blockchain. Record keepers, Factum, and my DocSafe are all trying to work on this in an open, accessible way. So when I create a sub-account in these blockchains, I'm then able to determine who has access to view this information, who has access to modify this information, and anytime a document has been modified, I can see who modified it, when it was modified, and what was modified. And it's completely auditable and verifiable through a trustless third party, because every document is stored in that blockchain from the inception of the blockchain. Now, my doc safe is really trying to take over notaries and other public figures that say, or that act as that trusted third party, that say, these two people have signed this document, this exact version of the document, here on this date at this time. If this is all done in blockchain, I can use a computer as that trusted entity, and I no longer have to pay those fees to the notary or some other lawyer or law office to be able to make sure that this is legally binding. So I'm sure those have brought up a couple of things. So I do have a couple of predictions looking towards the future. One of my first predictions is really that a large number of blockchains initiatives will fail. Currently, I would akin where we are in blockchain technology to 1998 in the dot-com era, very much where nobody knows how vast this is going to get, all of the uses it could be. Nobody knew that Facebook was going to be the monstrosity it was back in 2008. We're very similar here. How many people remember Lycos? It's another company that was competing with Google and all of these other search engines like Yahoo and Ask Jeeves. A multitude of those things failed because there was a lot of overlap. There is currently a lot of overlap, as you saw in some of my examples, for what types of blockchains are being developed. And that's going to cause, in the future, a number of these to fail as one gains more adoption over another. My second prediction is that we're going to see more common uses outside of finance. So right now, as we saw in the survey that we had at the beginning of this talk, most people think of cryptocurrency and blockchain as a financial vessel. But really, again, it's just a store of data, a store of assets. We're going to start seeing blockchain meet more Internet of Things and artificial intelligence applications. With this mass data store that's available to us in blockchain, either on a transaction level or on a data store level, artificial intelligence will be able to start mining that information anonymously. So right now we have the worry with Google Home that it's listening to everything I'm doing and it's associating it back to me as an individual user. If you were anonymized and all I wanted to know was usage data, but I could care less who you are, by putting this in blockchain, it allows us to aggregate that information without ever getting any personal information from you, the end user. Smart contracts, my fourth prediction, smart contracts will start coming into their own and developing completely autonomous companies. As we saw with Arcade City trying to replace Uber, we're going to see more and more companies develop themselves on smart contract technology. And then lastly, I really do expect to see state-sanctioned cryptocurrencies. In the idea, if we could put an entire state-sanctioned currency on a blockchain, it would make taxes autonomous. We would be able to, every time a transaction happened, taxes could be taken out and automatically funneled to the government body, and then we would be able to pay for our taxes if it wasn't done automatically at the end of the year using these state-sanctioned cryptos. The reason I have a question mark at the end of this is because we're already starting to see this happen. There is currently something called Dubai Coin, which only residents of Dubai are able to access, and they're currently able to use that to pay government entities and pay contracts. We're also seeing the creation of the crypto ruble and other similar currencies throughout the world. This has been a major topic, not only in trying to regulate cryptocurrencies and blockchains, but also in the use of how can government use this to better facilitate their processes. That being said, I wanted to thank you all for joining our webinar today. And at this point, we are opening it up for some questions. Currently, it is 1:40, so we have about 20 minutes left for questions. And I'm going to start doing this in a queue. So I'm going to have Chris Jorgensen read the question, and then I will answer. So please, if you have a question, enter it into the chat, and we'll start going through the queue.
Thanks, Scott. So our first question comes from Sherry, and she says, sounds like there's a strong belief that cryptographic technology is not able to be penetrated by the bad guys. What is that faith based on?
So that faith, and I may be getting a little bit out of my depth here, and I do want to highlight that. So that faith is based in current cryptographic technology. I am by no means a cryptographic specialist. And those same hash functions are being used in defense networks and automated processes in government sides currently. Now, with quantum computing, I completely understand that there are potential issues with that cryptographic function as computers become more powerful and more effective. So this is something that we're definitely watching. At the end of the day, the use of the cryptographic function outside of anonymizing a participant is really there to reduce the amount of data transfer from our transaction set. So currently, as an example, Bitcoin's blockchain is somewhere around 80 or 90 gigs of information. We're not trying to compare 80 or 90 gigs of information every 5 or 10 minutes when a new block is added. That's the reasoning for condensing it down into that 20-digit code. So I'm only sending 20 characters across the network. I do agree that this is something that needs to be watched over the next few years to determine whether or not access or anonymized participants are not able to be backwards, what's the word I'm looking for, able to be traced backwards from that 20-digit character.
Scott, next question comes from Terry, and she asks, for public chains, how can we be sure the info on the blockchain is reputable? Because garbage in, garbage out.
That's a great question. So there is a centralized protocol, and the only time a transaction happens is when one wallet user sends information to another wallet user. Now, when I send that transaction from one to the next, there is a small transaction fee. So it is much lower than an Amex or a Visa or a centralized credit office, generally to the tune of 0.1 or 0.3% currently. Which is much less than our 1 to 3% transaction rates now. So the cost of doing that transaction is really the starting prohibitor to putting bad data in. It really depends on the blockchain that's going through. For example, Ethereum probably does have a large amount of test smart contracts on the blockchain that are taking up space and processing power. So this really is up to the methodology of each blockchain to try and determine what is garbage in and how do I reduce the ability for garbage data to be added to this ledger.
Also from Terry Scott, she asks, what types of associations or industries are going to benefit the most in the short term from blockchain technology?
In the short term, I think that this is really going to aim for governance. So right now I know that there is a major problem amongst companies or associations with large number of companies under the umbrella, especially those that are not centralized in a single nationality. So being able to conduct governance, polling, voting, and rights structures through a automated program is one of the bigger benefits that I see. Another major benefit is in being able to audit information across companies. So in the pharmaceutical industry, as an example, trying to take your information from the time the initial medicine ball is created for pills and that type of thing, and tracking that all the way through the process, you're then able to utilize that information and anonymize the participants in a drug study or in transaction information. I hope that made sense.
Thank you, Scott. Another question from Paul is, what's the difference between Ethereum and Bitcoin?
So back to some of my other examples, Bitcoin in and of itself is aiming to solve the problem of financial transactions. It's being used as a store of value, and it's meant to only provide transactions from a peer-to-peer network. Now, Ethereum is a smart contract-based blockchain. Its entire goal is the ability to add those smart contracts to the blockchain. And while people use it to transact currently, the goal of ETH, or Ethereum's cryptocurrency, is not necessarily to be a store of value, but really to act as gas. And what I mean by that is those millions of people that are currently acting as miners or as authorizing nodes in that network have to pay for their power, they have to pay for their hardware. So we need to incentivize those users. And the way we do this is by offering up mining rewards. So Ethereum is meant to be used by companies that have smart contracts to process the information in the smart contracts, and that transaction cost is then funneled back to the miners who get that as a reward for processing that information and being part of that collective network. So while it does have a value, the economy in Ethereum is really meant to be companies need this to process their information. Miners get this as a reward, and then miners would then sell this back to those companies to then process more data, creating essentially a digital economy.
Scott, next question is from Paul. He says, how will blockchain technology affect associations specifically in the area of membership?
So in membership, there's probably a couple of ways that this will affect it more in the immediate nature. Again, going back to the governance side, as far as managing what members' rights are, if there's a voting structure, thing of that nature. It may be able to be used for member identity. So if you had a private blockchain and you were trying to share that membership across multiple associations or multiple different properties, you could use the blockchain to hold that information and all of the information from these sub-properties. And you can also do this for maybe a gift card or a loyalty program. So every time I make, in the case of a sales organization, every time I sell something under this membership, maybe I get a small benefit or reward, and then that's stored and paid out to me in that blockchain's cryptocurrency.
Thanks, Scott. Next question is, how is blockchain different from database?
So blockchain is, at the end of the day, blockchain is a database. The biggest difference between a blockchain and a traditional database is where it's stored. So in the case of blockchain, that information is stored duplicatively over every participating node or miner on the network. Whereas a traditional database, even distributed cloud databases, are owned by one party. So in this case, let's go with a website's database. It's held on the web server. It may be held over multiple servers, but there is one authority that has access to that information and has the ability to modify that information, making it you can't put trust in that unless you trust the authoring body.
Thanks, Scott. Next question from Jane. She asks, how long do you think it'll take for associations to adopt blockchain en masse?
I'm very uncomfortable answering that question. I think it will take a number of years personally. Very much like we saw at the dawn of the internet. If we go back to my 1998 example, most companies barely had a web presence, if any at all, until probably late 90s, early 2000s. That's when we started seeing a lot of poster card sites pop up. Only the big guys really had a website at that time. And that's when we were all dialing in via AOL, America Online, for those of you who were not part of that process. And really, we were all being centralized through our internet service provider. So as this continues to develop and as it becomes easier to develop blockchains, I think we're going to see it used more and more.
Excellent. Well, that is it for our questions right now. I'd like to thank Scott for his preparation today and for the thoroughness of this presentation. We will be emailing this out, a link to the recording for anyone who would like to rewatch it or share.
And as a last takeaway, I do have a slide up here that has information and links to common blockchain and cryptocurrency blogs, some of the more popular public blockchains, such as Hyperledger, Ethereum, Bitcoin, other learning resources, such as IBM's Knowledge Center, the Government Blockchain Association. And then for those of you that are interested in the investment and mining aspects, we have the cryptocurrency market values and other popular exchanges that are being used here in the US.
Excellent. Thank you, Scott. We'll also be doing a webinar each month. So we'll be in contact for all of you who registered for today's to let you know what our February webinar will be shortly.
The last takeaway I will say is if you are very interested in trying to develop a blockchain for your particular association or company, Hyperledger is one that is opened by the Linux Foundation and backed by IBM. So I would definitely take a look at Hyperledger, as it's completely open source and free to play with, and you can personally deploy your own blockchain and test these things out if you're a developer.
Excellent. Thanks, Scott. And thank you to everyone who registered and attended today for spending some of your afternoon with us.